Hello everyone. Today we will see this problem based on mesh analysis. We have to find the value of V1, which is across voltage current source 5 ampere. This is the given problem. As you can see this figure, there are two dependent sources. One is dependent voltage source and other is dependent current source. The value of these sources is depending on the value of V1. That's why this is called as a voltage controlled voltage source, and this is voltage controlled current source. The V1 is given here. It means the value of V1 is from this point to this ground. The value of V1 is voltage drop from this point to this point, or you can say this point to this point. This is the voltage at this particular node. V1 is the voltage at this particular node. As our first step is to solve this problem is our observation and assumption. So we have to assume the currents. Since it is a mesh analysis, we have to assume currents I1, I2, I3 in these three meshes. There are three meshes are there: mesh 1, mesh 2, mesh 3. And then we have to try to find out the value of V1 in terms of this I1, I2 and I3. So first we'll redraw this circuit. This 5 ampere is an independent source. This is I1, this is I2. All the three currents are flowing in the clockwise direction. We are assuming I1, I2, I3 flowing in clockwise direction. And then now we have to try to write down the value of V1 in terms of I1, I2 and I3. Now consider here the value of V1 is given. So this is nothing but, for understanding purpose, I am writing this is the value of V1. For this is positive and this is negative. You can see this in this way. This is the value V1, which is the voltage between this point and this point. Now if we apply KVL in this mesh, then we will get the value of V1. Apply KVL in this mesh. since current I1 is flowing through this, so here because of this I1, the polarities is positive and negative here. So if we apply KVL here, then we can apply KVL in mesh 1 to find out value of V1. Then I am not considering this 5 ampere now, I am considering this voltage V1. Since KVL is nothing but Kirchhoff's voltage law, summation of the voltages in a closed loop is equal to 0. That's why I am in this particular direction I am applying KVL. So I am going in the clockwise direction. So negative to positive V1, positive to negative, minus 20 into I1 minus I3, because in this 20 ohm two currents are flowing in opposite directions. I1 is flowing from this direction and I3 is flowing from this to this direction. So both are in opposite direction. But since we are considering this mesh 1, we have to consider this polarities because of current I1. So that's why I am writing minus 20 into I1 minus I3. The difference of the currents flowing through this 20 ohm, and by Ohm's law this is resistor into current is voltage. So I am taking this voltage drop across 20 ohm, and then again from positive to negative, minus 0.4 V1 is equal to 0. So V1 minus 20 I1 plus 20 I3 minus 0.4 V1 is equal to 0. V1 minus 0.4 V1 is 0.6 V1 is equal to 20 I1 minus 20 I3. 20 I1 minus 20 I3. So if 0.6 divide each and every term on the right side, so 20 divided by 0.6 I1 minus 20 divided by 0.6 I3. So V1 is equal to, getting 33.33 I1 minus 33.33 I3. So this is very important to find out the value of this dependent variable, that is V1, because we have to use this value afterwards. Now give this equation number 1. So here you will get 0.33 into 5 plus I2 minus 0.33 I3 equal to 0. This is 1.65 plus I2 minus 0.33 I3 equal to 0. So this is I2 minus 0.33 I3 equal to 0. So this will be your equation number 5. Now substitute I1 is equal to 5 in equation 4. You will get 20 into 5 plus 30 I2 minus 100 I3 equal to 0. So here you will get 30 I2 minus 100 I3 equal to here you get minus 1.5. This will go to the right side, minus 1.5. Here 30 minus 100 by 3 minus 100. This is equation number 6. Now to solve using calculator, using calculator I am solving this. See, equation 1, two unknowns, a1 is 1, b1 is minus 0.33, c1 is minus 1.65, then a2 is 30, then p2 is minus 100, and then c2 is minus 100. You will get this answer minus 1.46. So your I2 is minus 1.46 and I3 is 0.56. So your I2 is